at unknown moons, which are natural satellites that can orbit around other planets. And most of these moons are not going to be spherical. But we're also going to take just a short look at moons that orbit other exoplanets. So first of all, let's have a quick introduction. But before we start, I have a question to ask you guys. How many moons do you think are in the solar system?
5,000.
5,000?
That's my guess. Yeah.
Okay, that's 5,000. Anybody else?
68.
You?
100.
100? Anybody else? Here?
Yeah, billions.
Anybody else?
42.
135.
Okay, anyone else?
2,099.
Okay, anyone else?
10,000.
What? 10,000? 10,000?
10,000.
Oh, okay, anybody else?
Yeah, your sister.
Anybody else?
Your sister's got a hand up.
I'm not going to get it to you. You're literally going to say, like, the correct answer. So I'm not letting you spoil it. Anybody else?
Go.
Is that it?
Yeah.
Who said 135? You? Come and get your prize. You were still like 420 off. But you were the closest. Come and get your prize.
And that, by the way, is John, who works at the Gemini Observatory in Hawaii.
Alright, back to the introduction.
But give the answer, Jose. Tell us the correct answer.
Not yet,
Oh.
but I will, but just not yet. So what is a moon? A moon is an object that orbits like a planet, a dwarf planet, or an asteroid. And it can be considered a natural satellite and can vary in mass, size, and composition. Boise, a tiny moon right here, as you can see, it is not spherical. But other moons like Callisto, Ganymede, Europa, Io, even our moon itself, which is out there. Here they are, all compared with Earth. Some of them are not spherical, like Puck and Phoebe and Hyperion, but most of these are indeed spherical, like Triton, Charon, Ganymede, Titan, or even our moon. Now, how many moons are there in the solar system? What I meant by 135, if I asked how many moons orbited around planets, you would whoever said 135 would definitely be the closest, because that'd be only 50 off. What I meant by moon is to include moons that orbit around asteroids. And I included them, and if you were to include them along with the dwarf planets and planets, it would give you 555 moons. So 185 moons orbit around planets, 9 orbit around dwarf planets, 75 orbit around near asteroids, 29 orbit around Mars-crossing asteroids, 173 orbit around main belt asteroid moons, 5 moons orbit around Jupiter Trojans, and 96 objects orbit Trans-Neptunian objects. And that means that putting it all together, there are also 2 centaurs that are said to have rings that can be called moons. But the centaurs I don't include. I think that means it should be 553, but still, if you were to include the centaurs and include the rings as moons, you would have 361 minor planet moons. Now, the most popular moons you have like Enceladus, Dicynoma, so these are objects of the solar system, starting with Enceladus. Of course, there are smaller ones, trust me. There's Mimas, there's a lot of objects that still have to go here, but still, this is a lot. This is just like a quick trailer of the essential popular moons, but there are 33 of these well-known moons out of 555 of all these moons. 1 moon belonging to Earth, 2 Mars, 4 Jupiter, 9 Saturn, 3 Neptune, 9 dwarf. So now we're going to look at the categories of moons. So, first of all, you have regular moons that orbit follow See, in our case, Jupiter would be revolving around like this. But as you can see in this animation, regular moons are moons with a close and prograde orbit. As you can see, it just goes around an orbit that follows the rotation of the parent primary. So they must have formed in orbit with their primary. They have a low orbital inclination, which is just the tilt of everything, and eccentricity, which is like how much it gets weird. Like, the more an orbit looks more weirder, the weirder an orbit looks like, the more eccentricity it technically has. Yeah. So there are 68 of these moons. Our moon, Mars' moons, 8 of Jupiter's moons, 23 of Saturn's moons, 18 of Uranus' moons, half of Neptune's moons, and all the dwarf planet moons. Irregular moons, just imagine Jupiter orbits like this, then the other moons would orbit like this. They are said to be moons with a distant inclined and often eccentric and retrograde orbit. And indeed, they can be said to be captured by the parent planet as, like, originally asteroids. Mars' moons were captured, but some moons that are captured can orbit progrades. Now, there are 71 of these moons around Jupiter, 38 around Saturn, 9 around Uranus, and the other half of Neptune's moons. Now, minor planet moons are moons that orbit other, like, moons that orbit around asteroids and minor planets and kind of objects. This object right here, as you see, is 1994 CC. It's, or you can call it 136617 in parentheses 1994 CC. That's its like literal minor planet designation. Literal. So it has this tiny moon, and then it has another one over here. So you have one moon right there, and then so here it is, one moon, and then the other. They were both discovered in 2009. Here we have 243 Ida, which is literally the first asteroid confirmed to have its own moon. That dome, right here. That tiny little piece. And these tiny pieces are actually pieces of their parent asteroid. What? See, when an object hits another, sometimes a piece can be chipped off. And that's literally how minor planet moons form. And as of June 2019, we said that there are 361 such moons, and they help to know more about the planet, such as their density. Exomoons are natural satellites that orbit exoplanets. And we might have found the first one! Dun-dun-dun-dun! Kepler 1625Bi, making the first ever exomoon. But unfortunately, it just probably doesn't exist. But if it does, it would be a an object with 4 Earth radiuses in radius, orbiting around a planet 6 Earth radiuses, around a sun-like star Kepler 1625, with the moon orbiting around Kepler 1625b. Now, the existence of exomoons around many exoplanets is theorized, like WASP-12b even could have itself a moon, WASP-12b alive. But natural satellites are likely to be common elements of planetary systems. Do you notice anything different about this picture?
Yeah.
Yes. What is it?
There's another.
This?
Yes.
Oh! What's this?
Another moon.
What's this? What do you think? Does it orbit around the moon?
Yes.
Do we have such an object?
Yes.
Like, what's that? Well, they're actually called submoons, and they're known as subsatellites, moon moons, or gray moons. And Kepler 1625b itself might have a submoon, making the first known submoon, but which means that you have to add another I, because it's honestly it's a designation for a moon, but itself since it just probably doesn't exist, the submoon probably doesn't exist. So, but Iapetus might have possessed a submoon, and Rhea, which is one of Saturn's moons, could possess a submoon with a stable orbit. But let's just take a look at all these moons. So we have Jupiter You have the inner moons, Galilean moons, Themisto group, Himalaya group, Carpo group, Welchura group, Ananke group, Carme group, and Pasiphae group. Himalaya follows this kind of orbit. Himalaya is like it's the largest irregular satellite of Jupiter and is the 5th largest Jovian satellite with a diameter of 170 kilometers, the size of Haumei's smallest moon, Namica. It takes about 251 days to complete one orbit around Jupiter. Gee, that is long, but its orbit is continuously changing due to solar and planetary perturbations. As you can see in this animation, it's constantly changing. It was discovered on the 3rd of December 1904, and its proximity to the planet's brilliant disk makes it a far more difficult object to view itself. Alright, so Alethea is the 6th largest moon of Jupiter and is the 3rd moon of Jupiter in order of distance from the planet itself. But it was discovered on the 9th of December 1892. From its surface, Jupiter would appear 46.5 degrees in diameter. It is irregularly shaped and reddish in color. And it consists of various water ice with unknown amounts of other materials and has large craters and ridges on its surface. And indeed, has several prominent bright spots. Now, Saturn moons by group, they are the ring shepherds, co-orbitals, G-rings, Mimas and Alchemedes, outer large, inner large, Inwood group, Morse group, Gallic group. But there are 3 unconfirmed moons: S2004, S4, S2004, S3, S2004, S6. Those are their temporary designations. How about that? Now there are 2 hypothetical moons, Chiron and Themis, and by the way, you don't want to confuse them with 2 asteroids. So the 2 moons, Chiron and Themis, are now named after asteroids, 2060 Chiron and 24 Themis, respectively. Which, too bad we stole their names. Janus has a co-orbital orbit with Epimetheus, so you'll see that when the 2 moons reach there, they seem to loop back. As you see, they seem to loop back on their orbit. Like if you follow Epimetheus, there's Epimetheus right there. No, it's going in. You can't see it. There it is. And then if you follow Janus, Janus also just goes around and then loops back. This is called a co-orbital orbit. Each day in some kind of overtaking where the inner moon gets closer than the inner moon gets farther than the outer moon. They kind of overtake their spots. It's like, hey, give me that spot. Fine, then I'll take yours. It's kind of like that. For example, if you were to want to steal her spot, you're like, hey, give me that spot, and then she's like, okay, I'm gonna get yours then. That's kind of what overtaking is like. That's kind of the situation. But so each day the inner moon is an additional 0.25 degrees farther around than the outer moon in this case. Janus is actually extensively cratered and has a very low density and relatively high albedo, so it would be pretty chilly there. There's a faint dust ring around the orbits of Janus and Epimetheus, of these co-orbital moons, but it acts as a shepherd. Now the green in this animation is Janus, and the pink, which seems to come out of the screen, is Epimetheus. And Janus acts like a shepherd. Epimetheus has a co-orbital orbit with that of Janus, and it has several craters larger than 30 kilometers in diameter. Janus and Epimetheus may have formed from the disruption of single parent to form co-orbital satellites. Besides, South Pole shows signs of a large impact crater, and it appears to be 2 Terratites. Now Uranus is 3 groups. The inner moons, which make up like half of the moons, yada yada in one group. The large moons, and then you got the irregular moons, which are just the retrograde moons of Uranus. Sycorax is one of these irregular moons, and it was discovered on the 6th of December 1990 something. 1997. Right. And it was given the temporary designation S1997 U2. Too bad it's not. Whatever. It's more than 20 times further from Uranus than the furthest regular moon Oberon, and it orbits retrograde moderately inclined and retrograde, which means that if Sycorax seems to have an orbit like this, Uranus should be orbiting like this. That dot is Uranus. The light blue is Francisco. The pink is Sycorax. The dark green is Trinculo. The yellow is Caliban, and the red is Stefano. We're not going to talk about all of these moons because that's going to waste our time. Puck is an inner moon of Uranus and is the 7th largest moon of Uranus with a diameter of about, what am I saying about? I mean, with a diameter of exactly 162. This is lying. It's 162. It's exactly 162. It's not 161.15 or 162.0001. No, exactly 1.162. It has a dark heavily cratered surface which shows signs of water ice. Okay, and it orbits between the rings of Uranus and Miranda, Uranus's smallest major moon, and it is spherical in shape. Not really, but it was given the temporary designation S1985 U1, as it was discovered from the images taken by Voyager 2 on the 30th of December in 1985. Am I saying 2085? That's in the future. We wouldn't have known about Puck. Puck wouldn't be a moon of Uranus. Puck is an inner moon of Uranus, by the way. So there are 3 groups. The regular group, which make up half of the moons. Trion group with 1 moon, which the Trion group is not really a group. It's just Trion. And then the irregular group with 6 moons, including Samathe, Nereid, Neso. Larissa is first discovered on May 24th, 1981, and is given the temporary designation S1981N1. It is irregular, not circular in shape, it is heavily cratered, with no signs of any geological modification, as it's called. Galatea! Galatea is a funny name. I can say it all day. Galatea. Galatea was discovered in late July 1989 from the images taken by the Voyager 2 probe, and it shows no signs of any geological modification either. And it appears to be a shepherd moon for the Adams ring that is 1,000 kilometers outside its orbit, or 600 something miles. Reasons of Galatea in the ratio 42-43 are considered the most likely mechanism for confining the unique ring arcs in the Adams ring. Now, these are going to be interesting moons that are going to blow your entire mind. Like, I don't know. Kind of like that. Charon, first of all, it's not orbiting around Pluto. See, that's Pluto, that's Charon, that's Nix, Kerberos, Styx, and Hydra. So yeah. It was discovered by the United States Naval Observatory astronomer James Christie using the 1.55 meter or 61-inch telescope at the United States Naval Observatory Flagstaff Station, NOFS. NOFS. It does not orbit around Pluto, orbiting in this sort of binary system that looks beautiful from the side. It's called a double planet system. There's another new Triton that we're going to look at that wasn't a double planet system in the past. We're going to look at it just a bit later. It was originally known by the temporary designation S1978P1 as it was discovered in 1978. Titan, which maybe it's too big, but it has an atmosphere with a probe called Fusions on it, and it could have life. So Fusions was just sent. And Fusions is now seeing the sight of methane rain on Titan with nitrogen, which isn't that bad, but of course we need oxygen, so we're almost there. We almost got everything we need to live on Titan right now, but the only thing we don't need is oxygen. It is bigger than Mercury, even makes it the 2nd largest moon in the solar system after Ganymede, the giant of the solar system. Europa is a world in total darkness, as it's called, and it's the smoothest surface. It has the in the solar system. Indeed. It's primarily made of silicon rock and has a borax crust and probably even an iron nickel core. With a very thin atmosphere composed primarily of oxygen. That's the right word. Composed. That's the right word. One time it might be habitable with evidences suggesting the existence of lakes and liquid water entirely instead of Europa's icy outer shell. Enceladus has a wide range of surface features and is mostly covered by fresh clean ice, making it one of the most reflective bodies in the solar system. Oh, nice. There is evidence of liquid water in it, which still we shouldn't try drinking it yet. The presence of ample hydrogen in Enceladus' oceans means that microbes, if any, exist that could use it to obtain energy by combining the hydrogen with carbon dioxide dissolved in the water. And it's called methanogenesis. That's literally like a process. Okay. It's losing mass at a rate of 200 kilograms every second, and it's trapped in an orbital region. Tridot is what we said, and is said to be captured from a double planet system. So Neptune was kind of a double planet system, but when Neptune came into the double planet system, it fling the other object out. Hope it's orbiting around some sort of object right now. But Tridot was then captured, so it orbits retrograde. And it's said to just break up into a ring around Neptune. A ring like Saturn, giving us 2 beautiful planets. 3. Sorry, I'm being mean to Earth. 3. I meant 3 beautiful planets. And it has a tenuous nitrogen atmosphere with carbon monoxide and methane. Wait, did I say the ring is going to break up in a billion years? Because if I didn't, I'm sorry. It launches stratosphere and instead has a thermosphere from altitudes from 8 to 950 kilometers and has an exosphere above that. A post-capture orbit would have also resulted in tidal heating of its interior, which could have kept trying fluid for a billion years. So, to sum it all up, moons are being discovered. Wild things are being discovered every day, just making us wonder how big our humongous universe is. But it's just also making us wonder just how many things are out there left to discover. Any questions? Oh wait, I forgot to ask you the final question. And whoever gets the closest, again, there's going to be a prize. So, you have to pay attention. You have to be a good memorizer. You have to remember what we were talking about on the slide about how many moons were in the solar system. You have to remember, 20 or 30 minutes ago we were talking about that. So, you have to be good at remembering things that long ago. So, the question is, how many moons, or minor planet moons, are in the solar system? How many moons orbit around asteroids and minor planets and Kuiper Belt objects?
555.
333.
555.
Okay, that's it. I heard 2 people, you guys said 361. Did anyone else say 361? Who else said 361? You? Who else? Is that it? 3 people? 4? Did you say it?
I said
Wow, that's a lot of people tied on the correct answer.
Let's ask them an easy question. Name the moons of Uranus.
Well, wait, what? How about, let's go for a bit easier. Name
The smoothest one.
Yeah.
the moons of Pluto. It's only 5 of them, that's all. Okay, name the 5 moons of Pluto.
I can name none of them.
Okay then. None of them? Alright.
One, Pluto, 2, 3.
So three people had the close answer, right? Come and see me.
Did you say 361? Did you say 361?
What? Let me give it a prize then.
Yeah.
Yeah.
Come and see me.
Yeah, so 3 people tied on the correct answer. Oh, wow.
I have a question for you, Jose.
Wait, what?
I have a question for you.
What?
You use the concept of groups many times in your presentation. How do you determine whether something belongs to a particular group?
Well, first of all, the way we understand the irregular group is that usually the irregular group of Uranus and Neptune are retrograde moons. But sometimes you can also group moons into like inner moons, which are like the moons that are really close in. And then the Galilean moons of Jupiter, for example, are the 4 most popular ones. But we can just, that's what we know about it, but
So different reasons for each of the groupings, right?
different reasonings. Like, but the irregular groups of the ice giants are because they orbit retrograde.
Okay, thank you. Does anybody else have
Any questions? You? What's your question?
Why didn't you let me answer the question?
Because you would steal the prize. You already, you were with me when we were practicing. You already knew it was 560. Okay.
Okay, we have a question here.
The lady in the blue jacket has a question.
Okay, what is it?
I think it was Enceladus. It's a moon that's losing mass, and it's trapped in an orbital resonance. What is an orbital resonance?
It's like some object completes some amount of orbits at the same time that another object completes another amount of orbits. Revolutions. For example, a 2 to 3 resonance with for example, let's say Neptune completes 2 orbits while another exoplanet completes 3. That'd be like an orbital resonance 2 to 3.
Any other questions? Anyways, thank you.